What's going on, my ASVAB party people? Anderson here, your ASVAB coach. We've got a nice 2-hour session recording on distance rate time for you. Oh, that's actually not showing because it's the Black Friday holiday sale going on now. So in case you didn't know, well, I'm pretty sure you know, 8 out of 10 people failed the ASVAB on their first try. Seriously, 8 out of 10. That's a scary number because people just aren't prepared to take the ASVAB. And it's not really your fault. You got to figure out what to study, how to study. You got to know when you're ready. You don't have a support system. You have to battle test anxiety. You blank out on word problems. Tutoring's already expensive. All of these different issues might tell you to give up, but the thing is, you're not. You're watching this video because you want to ace the ASVAB. And so, if you're gonna ace the ASVAB, that means getting the job that you deserve and a nice bonus check at the end of the day. So how are we gonna get that done? Well, the way that we get that done is, again, through the All Access program. And so before we get started with this recording today, briefly, let me just tell you about it. You get all of the fun live classes where you can ask questions and feel like you're actually part of a program that works for you. You'll get the recordings too, so you can watch them whenever. On top of that, you'll have over 2,000 extra practice problems with video solutions for the math. Because who wants to read math out of a textbook? Let's be honest. So you'll get video solutions for the math, so you can really truly feel like you're building confidence. And then you'll have access to me all the way until you pass. Text me for anything that has to do with raising your score. You need help with a practice problem from my website? Great. From another website? Sure. Need help with a textbook problem? Shoot it over. Anything that can help you succeed, I will do. And so, I'm gonna put my money where my mouth is. Feel free to text me if you wanna learn more about the program, or if you're sold and you wanna sign up, let's go ahead and get started. Click the link in the description or in this post, wherever it may be, so that way you can start acing the ASVAB. With that said, sign up, show up, and then let's watch this 2-hour recording. Let's go. Let's go ahead. Oh, looks like I made a duplicate accidentally, but let's get ahead here and really understand first the basics of distance, rate, and time. So before we begin, on a scale of 1 to 10, with 1 being you hate it, you don't want to do it, I hate this, I'm scared, to 5 being I'm okay, if I use my notes, I can kind of get it through, to a 10 being I don't need my notes, I know exactly what I'm doing every step of the way. How are we feeling right now in terms of distance, rate, time? 4.5, just below, just below okay. So we see a lot of 5s, and I see a 7 there, good. I see a 1 there, a 4, 5, 5, 5, 4, 5, 5. Y'all are treading that line. Okay, so I don't see many people above a 5, which is, No, so J, a 10 would be, that'd be a 1 then, if you hate it. Okay, cool. So going through, thank you guys for participating there. 1, 1, 1, 1, 1. So no worries. Look, our main goal today is to go from hating it or discomfort or anxiety to being able to point out exactly which number is distance, which number is rate, which number is time from a word problem. So again, that's going to be goal number 1 for today. Being able to at least look at a word problem and say that's a distance, that's a rate, that's a time. So write that down. Goal number 1. Goal number 1 for today, right here. Just identify the distance, rate, and time. Distance, rate, and time. All right, that's our first goal for today. I'm going to reveal the second goal in a few slides, but I want everybody to write that down. Step 1 or goal number 1 for today is at least just being able to build that comfort and being able to say, okay, I know that that's a distance because it says this after the number. I know this is a rate because of this specific indicator there. I know this is a time because, well, it says seconds. So that's really what the goal is today. All right. So let's kind of get into, again, how we're going to identify these things. And there's one big misconception that a lot of people have who haven't done distance, rate, time problems. And it's this right here. Distance doesn't only mean distance. Now that sounds confusing. I didn't make the rules. They're the ones that wrote distance, rate, time. It's more like goal equals rate times time, not distance. Distance is more like the goal that you're trying to achieve. And so the goal could really be anything. It could be miles that you're trying to achieve. It could be a certain amount of money that you're trying to achieve. It could be this certain amount of water that's filled up in a pool. Do any of these problems sound familiar, anybody? So all of those problems that we've seen in the past that have to do with, oh, the rate at which you're filling up a swimming pool or draining a swimming pool, or the distance between two cars as they drive apart, or looking at someone who's trying to save money and they're saving for a few months, how much money are they going to have? Those are all technically distance, rate, time. All right. So let's zoom on in here. Distance. Distance is the amount that you're trying to accomplish or your goal. Okay. Distance is more so like your goal. That's what that is. Okay. That's what that is. The distance is more like the goal, the amount that you're trying to accomplish. The most common forms that we see are going to be distance itself, like miles, yards, feet, kilometers, etc. Nancy's trying to jog 5 miles for PT today. Or we could say that Amberlyn is on an airplane and that plane is trying to reach 12,000 miles, something to that effect. But here are the other ways that we can see it. Money, dollars and other currencies, definitely for sure. We see that Peter is trying to save $6,000 for his wedding. Cheapest wedding in the world, I know, but let's go ahead and say that there. And so again, what you're trying to accomplish, the goal can be considered a distance. One more example here, different amounts. Like weight, this is another one here. Like trying to achieve a weight goal. Like, hey, Brandon needs to drop 12 pounds to meet his requirement to enlist. If he's able to lose 1.5 pounds every month, how long will it take him? So again, that is it right there. That right there, we're talking about weight, but that's a distance, rate, time problem because you have a distance, the goal he's trying to achieve, the rate 1.5 pounds per month, and then we're trying to find how much time. Yes or no, everybody? Is this starting to make a little more sense in terms of how distance is not just distance? This is one of the biggest parts of today. Distance doesn't just mean distance. It means the goal. That's what distance is. The goal, what you're trying to achieve. Right on. So rate is pretty straightforward. Rate is going to come in a bunch of different shapes and sizes and forms and things like that. But there are always, always, always dead giveaways for rate. And so we're going to go through those. So remember that rate is basically the speed or the pace that you're trying to achieve that goal or distance. So rates sound like miles per hour, kilometers per hour, feet per second, dollars per hour, dollars per month, dollars per year. Everybody, by saying all those things and looking at these examples over here, what's the one word that I've been repeating this whole time? What's the one word I've been repeating? The word per. I have been repeating the word per, and don't worry, Loretta, I'm going to go ahead and zoom on out so everybody can get a chance here. But yeah, the word per. So key giveaways. So key giveaways for rates. Key giveaways. I'm telling you, this is like the Make-A-Wish Foundation. If you learn these keywords and little identifiers, you're going to be giving yourself the easiest time in the world when it comes to pointing these things out. So the word per is number one. Anyone else know of an example of another way to say the word per? It could be 2 words. What's another way to represent that in word problems? What have you seen if you have experience here? Each. There we go. That's one, Muhammad. Each is one of them. What's another one? Ooh, Eunice or Eunice. You tell me how to pronounce that. I had a neighbor in New York named Eunice, and so we pronounced it that way, but you let me know. Let me know if it's Eunice. But yeah, for every. For every. Eunice, sounds good. Nice to meet you. So yeah, for every. Exactly. So per, for every, anytime that you are mixing together two different units, like miles per hour, like dollars per hour. Anytime that you are mixing units, that is a rate. And it doesn't always have to be time, but we're not going to go in that direction in this class, simply because it's not necessary to be confident with distance, rate, time. Not necessary. And so next, anybody ever seen examples of reading? So someone's reading 27 pages per minute. Sounds impossible, I know, but that's another example. So this person can read 55 words per minute, or this person can read, 2.5 pages per minute, things like that. Pounds per month, raindrops per second. That's another one there. These are all examples of rates for the simple reason being per. Another example could be, you need 3 gallons for every 20 miles you drive. That's also a rate because you're mixing 2 units together every time. And so I'm going to zoom on out. That way you get the chance to copy this down, take a picture if you'd like to. But there's something even more important when it comes to not just knowing how to identify the rates, but it's about the story of the problem. Yes or no? If you've heard me say it before, give me a yes or a no. Have you ever heard me say that word problems are all about following the story? Nice. Right on. And if this is your first class with me today, well then, welcome in. But remember that with word problems, the biggest key that we're going to learn is that word problems are all about telling the story. They're all about breaking it down. Break down the story. And so in those stories, we need to make sure that we can identify distances, rates, and times without question. And so what we're going to do here is we're going to move into this next slide here. And we're going to break things down first by just identifying what we're looking for and what we have by simply looking at the keywords. And then we're going to introduce the formula to actually solve the problem. So here we go. First one coming up. A car travels, and I'm actually going to read the whole problem. Don't worry, we're not going to do the whole word problem strategy bit right now. I'm just going to read the story to you so you can hear the units, okay? So a car travels at an average speed of 60 miles per hour for 9 hours. How far did the car travel? Those are your keywords right there. A car travels at an average speed. Everybody, speed is synonymous with what other word that we're learning today? Speed is the same as saying what? Rate. Yeah, speed is the same thing as rate. So I'm teaching you how to identify these keywords here. Speed is the same thing as rate. And so speed of 60 miles per hour. So one more time, everybody. Speed gives it away for your rate. What else would give it away for rate? What other words or word? The word per. Exactly. The word per gives it away. Miles per hour. Per hour. Right there. Sweet. Now, everybody, up next. The word hours signifies what type of unit? Yep, that's going to be time. Exactly. Yeah, that's going to be time. That one's not terribly difficult. 9 hours. I think we know that hours is time. And then everybody, lastly, when it says how far, whenever we're asked how far, what can we assume? How far can you throw a baseball? How far can you roll a bowling ball? How far can you run? How far can you fly? We're talking about distance all day. We are talking about distance. What we want. And so, everyone, before we continue, I want to ask you, does that make sense here? The method by which we found these keywords for these parts of the formula. Does that make sense? Rate, look for things like speed, pace, per, for every. That's what you're looking for. If you're trying to identify time, well, look for seconds, minutes, hours, days, weeks, years, decades. Look for that. And then for distance, anything that signifies the goal that you're trying to achieve. In this case, how far we traveled. That's the distance. And so the last thing I'm going to say before we move forward and really put together the formula is this. You will never put together your formula, which is going to be D equals RT. Again, distance equals rate times time. You will, and let me actually write it down completely since it is the first time I'm presenting it. So distance equals rate times time. So I'm going to make sure that you see this very clearly before we begin, because I'm telling you right now, if you don't pay attention here, I'm going to show you that you're going to get tricked and exposed in a few problems. So if you're not paying attention right now, this is on you. This is what you want to pay attention to. When you're looking at the distance, looking at the rate, looking at the time, you got to make sure that those are all talking about the same event or same idea. Everybody, pop quiz, proportions, pop quiz on proportions. Everybody, what is my main rule about proportions? Feel free to grab the mic if you'd like to. What is the main rule about proportions if you've been to my classes? What is it?
Set up the same things in the same.
Yeah, comparing the same things the same way.
Yep, same things to the same way. Yep.
Yep. So if this is your first class with me today, I teach in a way that's easy to remember. I simplify it in English. And so with proportions, the idea is to compare the same things in the same way. With distance, rate, time formulas, you need to make sure that you're setting up the formula talking about the same thing. The formula, every part of the formula needs to talk about the same thing. So for example, over here, let me just show you what I mean here. The rate of 60 miles per hour is talking about the car. The time, the 9 hours, is talking about how long the car was traveling. The distance, we're looking for how far the car traveled. Every single part of this problem, let me let Ben in there, but every single part of this problem is talking about the car. Every single part of this problem is talking about the car. Does that make sense, everybody? We're going to look at other examples where there's going to be more than one thing there to really look at, but it's all about making sure that every piece is representing the same thing. That's the biggest piece of advice that I can give here. And so earlier, identify the distance, rate, and time, and how you're going to do that again, organizing it by each individual thing in the problem. If there's only one thing, one distance, one rate, one time, great. But if there's multiple, that's going to help you out. So let's fill in the formula, everybody. What are we going to put in for distance? What are we putting in for distance over here? What are we putting in for distance?
A question mark, because we're looking for the distance, right?
Right on, Andrea. Thank you. That is it. That's right. We are looking for distance. So we're just going to put a question mark, or we can just leave it as D. Everyone, what are we plugging in for the rate? Edgar, that's funny. But yeah, we're going to be putting in 60 for the rate here. We're going to be putting in 60 right there. And then for the time, what are we putting in, everybody?
9 hours.
9 hours, correct. And so we have 60 multiplied by 9, and that should give us the distance. So everybody, 60 multiplied by 9 gives us what? Nice. 540. Right on. So distance equals 540. 540 what?
Miles.
Yes, my phone.
Exactly. Because remember, this is your distance. This is your time. And so boom, when you find your answer for distance, it's going to be in miles. And so right there, 540 miles. All right. So moving forward, we are going to now continue incorporating the method for word problems for every single one. But I needed to take you to the story first just to make sure that you were good there. So Yes or no? Is everybody good to move forward? All right, sounds good. And remember, if you have any questions at all, I got you, all right? Don't worry, you're not slowing anybody down. Asking questions is part of the growing process. So number 2 here, let's take a look at this example. Now, everybody, what we need to make sure we do every single time, and I'm going to lower this a little bit because I know the recording button is in the way. So everybody here, the first step to every single word problem is to do what?
Read the question.
Question.
Read the
What
question.
brainwashing people? Yep, read the question. Yes, read the question. Now, can someone raise their hand and kind of explain why it's so important to read the question? Like, why is that the first thing you should do? Valerie, go ahead.
Because if you start from the beginning, you're gonna read information that you don't even know what they're for. But if you read the question, you'll know what they're asking you.
I love it. I love it, exactly. And so, David, I saw you raise your hand too. I want to see if you want to say that in a different way, because I'm going to try to combine what you both are saying here. If you want to go ahead, David, you can.
All right, so basically you want to read the question first just to get a gist of what they're asking you and what the sentence is going to be about, because if you're just reading along, then you won't really get a grasp of the information or something like that.
No, right on, man. And so Valerie and David, you guys are both spot on here in the sense of when you start with the question, what you're allowing yourself to do is to not put yourself at risk of getting confused by all of the information in the problem. So think about it like this. Would you rather have every single tool in your toolkit, like your hammers, your wrenches, everything, your literally anything, like your saw, whatever the heck you can think of, having all of those tools in front of you, a big pile mess, and then you're told what you need to do? Or would you rather look at what you need to do and then say, okay, I'll just need a screwdriver and these nails and we're good? Which way sounds a little more calm and peaceful? The second way, the latter way, for sure. Because when you first look at it and you have the goal, then from the goal, you're saying, okay, this is what I'll need. Not, here's everything you have. Let's go and stress you out and walk you through the entire inventory. And then let's go ahead and show you the problem here. No, that's not how life goes. Life goes, there's a problem. Let's come up with ideas and let's solve it. That's life. Treat math word problems the same way as life. What's my problem? Okay, what do I have to work with here? And what can I do? That's what this is all about, all right? So that's why we read the question first. So step 1 here, read the question. So when we read it here, start here. What? So you go for the things that say who, what, when, where, why, which of the following, how many. That's what you're looking for. So what was Jacob's speed in miles per hour? So everyone here, what am I underlining? What am I highlighting? What am I looking for? And how do I know?
You're looking for weight.
And how do we know?
Because of the pure.
The question mark.
Sounds good, right? I'm going to helping somebody out real quick. Whoever has iPad, they're having trouble with their microphone or hearing. So I'm going to go ahead and hook them up real quick. So if you're having trouble with your mic, please click the up arrow and select an audio output or check your volume. Just in case. I've had that happen to a few people that they couldn't hear me and then they're like, oh, just hit a mute. But yeah, so again, the idea here, we're looking for the question here. What was Jacob's speed in miles per hour? And the giveaway for rate was what again?
Per hour, miles per hour.
Not per, but per. Yeah,
Per, yeah.
Per.
Per. Per. I messed up.
You're good, you're good. So miles per hour. So right over here, we're going to go ahead and just highlight what we need. What was Jacob? So what was speed miles per hour? That gives it away right there. We want rate. But this is where I'm going to get into the whole again. Whose rate? What's rate? What are we talking about? The rate for what, everybody? Give me one or two words here. Rate for what? What are we looking for?
Jacob's speed.
There we go. We want Jacob's speed, Jacob's rate. Yes, we want Jacob's speed. I'm telling you right now, it may not be useful for this problem, but it will be when we get to that problem. You're gonna be like, oh, I see why he was setting that up for us. I got you. So we want Jacob's speed, and that's going to be miles per hour. So blank miles per hour. Is everybody cool with me using R for rate?
Yes.
Does that make it?
Yes.
Were you asking if that makes a difference? Is that Valerie?
No, that wasn't me.
No worries. I think someone was asking if that makes a difference. The letter you use, it doesn't. You can use X, you can use Y, you can use potatoes. Doesn't matter. Doesn't matter. And so with that, let's go ahead and take a look at the information that we're given here. So look, we're looking for Jacob's speed, everybody. So that means if we're trying to use the distance, rate, time formula, we are going to need Jacob's distance and Jacob's time. If we see Cassidy's distance, or we see Penelope's distance, or we see Roger's distance, none of those matter, except Roger's actually here, so sorry about that. But what I mean is, you know what I'm saying? Keep it consistent. The same numbers need to represent the same thing, okay? Or the different numbers that you'll see for the formula need to represent the same thing. Per means rate. That's right, Taylor. Yeah. And so next up, I'm looking over here, 1800. Everybody, what's the key word that will tell me what this is?
Miles, the distance.
Right there. Exactly. Miles gives away that this is distance. And so boom, we have 1800 miles. And then we have for what? What does that give away?
Time.
Yeah, that's going to give away time. 4 hours. So this is a distance. And then we have 4 hours, which is time. So we can set this up pretty fluently here, because we have distance equals rate times time. So let's ask ourselves here, everybody, what is the distance that we have? Give me.
1,800. 1,800.
That's right, 1800. And then what do we have for the rate or the time? Which one is it that we're looking for again? That's right, we still have R. And so we're looking, and we're given the time, which is 4. And so we have 1800 equals R times 4. Everybody, is it legal to write R times 4 as 4R? Can we just do that? Is that okay with you?
Yes. Yes.
Cool. I know some of us may be a little anxious about looking at things like that, and you might not know that that's the same thing as saying 4R. Just want to make sure I reinforce that. So we have 1800 equals 4R. So everybody, what's different from this problem than the previous problem that we just did in terms of how we're going to solve this?
We're looking for the rate.
Yeah,
And the other one, we were looking for the distance.
that's correct. So when you're looking for the distance, you're working forward, and notice how you just straight up multiply. When we're finding the rate over here, notice that the rate isn't by itself yet. So we have to do division. That's correct. Stefan and Devin, correct. We have to divide here. And so everybody, what must we do to both sides to get the R by itself?
Divide by 4.
Divide by 4. That's right.
On both sides.
Exactly.
On both sides.
Thank you, because I'm going to start getting annoying with it in a bit. But here, we have 4 being multiplied with the R. Remember that solving equations is the art of working backwards. And so if we're currently multiplying 4 with the R, to get rid of that 4, we must perform the opposite operation and divide to both sides to keep the balance. But right here, it's going to cancel out, because if you're multiplying by 4 and then dividing by 4 right here, multiplying and dividing, that cancels out. The same thing, by. So now we just have to take care of 1800 divided by 4, and we're done. 1800 divided by 4 is the same thing as dividing by 2 twice, but I'm going to show you the long division first to explain that quick little bit of mental math. So 4 going into 1800. 4 goes into 18. How many times, everybody? Hit me.
4.
4 times. So minus 16 gives me 2. Everybody, 4 goes into 20. How many times?
5.
Correct. Goes 5 times minus the 20. Bring that 0 down. That's no remainder. And we have 450. And so the answer will be the rate is 450 what?
Miles per hour.
Miles per hour.
Coach, will we
Miles per
still
hour.
do it the same way if we were missing the time instead of the rate?
Yeah, because you still need to divide to get it by itself.
Okay.
Exactly. So if you're looking for distance, you're multiplying. If you're looking for the rate or the time, you're dividing. Basically it. The distance is the result, the goal that you're trying to achieve. And remember, I always say this, whenever you're trying to get to the goal, you're always multiplying or adding. But if you're trying to work backwards and find a piece, then you're always dividing. So great observation, Jose. Yeah, that's right, Kevin. We can't do anything else. 450, boom, right there. It's nice. So Frida, the formula is distance equals rate times time. Whenever you're looking for the distance, you're multiplying the rate and the time. So I can show you over here. So whenever you're looking for the distance, notice how that's rate and time multiplied together. But if you're looking for the rate, notice how the time is in the way. You got to divide that out. Likewise, if you're looking for time, notice how the rate is with it right there in the way. So you'd have to divide the rate out if you're looking for time. So that's what we mean there. That's what we mean in terms of you're going to be working backwards for the pieces, forward for the goal, forward for distance. And we'll get plenty more examples with this for sure. But yeah, so there's the screen full. Let me go ahead and move myself out of the way there. So there it is. With that said, how easy or how doable was it to identify each of the distance, rate, and time in this problem for you on a scale of 1 to 10? How easy was it, with 10 being the easiest?
10.
It'll be easy if you remember your key, like the miles, what is, because if you know those, then you're good, like you said in the beginning.
Oh yeah, for sure. Oh yeah. And again, it just takes time, but you can definitely get there. It's all good, David. It is all good. All right. So with that said, what we're going to get into now is we're going to be looking at, again, another problem here. So here we're looking at miles, but let's go ahead and see if there is another way. No worries, Charles. I got you, man. So let's take a look at another example here. We're going to point things out just one at a time. And I'm going to reinforce those ideas. So over here, everybody, what did I say? First thing we're going to look at with every word problem is what?
Read the question.
That's right. We're going to read the question. So everybody, let's start with the question here. Let's start with the question. How many laps per minute can Adam run? Everyone, what's the dead giveaway of what we're looking for here in this problem?
Time.
Not time. There's a key word in the red highlight
Per
there.
minute.
How many laps
Per minute.
per minute? How many laps per minute can Adam run? Right there. Laps per minute. So we are looking for what? The distance, the rate, or the time, everybody?
Time.
Time.
Rate. Rate.
What's the dead giveaway for rate?
Because it's saying laps per minute.
Per.
And that
It says
per
per.
minute. And that's the rate. We have
Right
the
there,
time
per.
because of
The
5
hand
minutes.
right.
Yeah, per is what gives it away right there. Per gives it away. Per is what gives it away. So we want blank laps per minute. And that is always going to classify as a rate. Again, the word per means rate, okay? So like dollars per hour, the wage that you earn at your job, whether it's 10 bucks, 15, 25, 30 dollars per hour, that is your wage and that is your rate. How quickly you earn money, the pace at which you earn money. Here, laps per minute. That is the pace at which you complete the laps. How quickly you can complete one lap. That is your rate. That is your pace. So I'm hoping that if you think about it in the real world, like frame, laps per minute, that's your speed. How quickly you're moving. And so let's take a look at the information that we're given here. Everyone, this is how you can tell really easily what units the distance is and what units the time is in. Remember, the rate connects the distance and time. Distance per time, miles per hour, laps per minute. So everybody, what should the distance be? What should the distance be? Not the number, but the representation of the number. What would the distance be?
Laps around the basketball court. 22.
Yes, laps around the court, right there. That's right there, laps, right there. That is distance. Excuse me there. Use black actually. Distance equals blank laps. And everybody, what number do they give us for laps in this problem?
22.
22.
22 laps, right there. 22 laps. And then next, we see that Adam runs 22 laps around the basketball court every 5 minutes. And so right there, what does the 5 minutes represent?
The time.
The time.
So before we continue, I want to make sure that we are on the same page in terms of how we actually point out laps per minute, how we pointed out that as being the rate, how we point out 22 laps being a distance. Does that make sense? Especially Charles, I want to go ahead and make sure I take care of you, boss. So does that make sense there? How we got the rate being laps per minute, how we got the distance being laps, 22 laps, and how we get the time being 5 minutes? Is everybody here good? Right on. And even if we are still confused, remember, it's pointing. What we're doing here is pointing out these key words. All right. What we're doing here is pointing out these key words. And so, with that said, everybody, what I want you to do is type out into the chat box. I want you to type out into the chat box, hey, the formula that we're gonna complete. Type it in. I know it's distance equals rate times time, but replace the formula with the numbers. Don't do anything yet. Just replace the formula with the numbers and type them into the chat box right there. Let's see what you got. Got 5 people so far there. 22 equals R times 5. 22 equals 5R, R times 5. Those are both correct. Those are both correct. Right on, everybody. I like seeing this. Exactly. When we plug everything in, what we're going to have here is distance equals rate times time. And so our distance is going to be 22 laps. Our rate is what we're looking for. So we'll just keep that as R. And then the time is 5 minutes. Right there. And so we can change that over to 22 equals 5R. And so our plan, everybody, is to do what to both sides now? What's our plan?
Divide by 5 on both sides.
Oh, yeah. There it is. Divide by 5 on both sides, and we're good. Divide by 5 on both sides, and we are done. So here we are. Divide by 5. Divide by 5. Everyone, 22 divided by 5. We may need to use a decimal here. That's okay. That's okay. So we'll zoom on in. We'll go ahead and divide 5 into 22. 5 can't go into 2. 5 goes into 22. How many times? 4 times.
4 times.
So then we subtract the 20 because 5 times 4, that's going to give us 20. That's how we get there. So we have that 2 left. And what's left to do here is we're going to go ahead and apply a decimal place. Bring that 0 down. And we're going to have 20 here. Everybody, 5 goes into 20 how many times? 4.
4.
Correct. And so we have 4.4. Everybody, the answer is R equals 4.4 what? Units, come on.
Laps per minute.
Laps per minute. Laps per minute. Because again, that's the rate. We're looking for the rate. And so it has to be in laps per minute. It has to combine the two units. Laps per minute. Is this making a little more sense for anybody out there? And if we are still confused, I want you to let me know. Raise your hand if you want to use the mic, but let me know what you did understand, and then let me know what the point was that you got stuck at. So go ahead. I'm giving you the mic there. Go ahead, Savia.
Cynthia.
Savia.
This is it doesn't have to do with this, but the question I do have, is it ever going to be a situation where you have to like do rate like divided by distance equals time, or is it always going to be this formula?
No, yeah. So if we're looking for the time, yeah, we will be dividing the distance by the rate for sure.
Okay.
Yeah.
Okay.
And we'll definitely have some examples in here. We'll definitely have some examples of this.
Thank you.
Hey, not a problem. And so with that, I just need to learn how to plug into the DRT the right way. Yeah, Frida, that's really it right there. It's really knowing how to point out each piece of the formula. That's really what it's about. Devin, go ahead.
Yes, hi. I understand how to solve the problem, but I had a question with the last part with the 4.4 lap per minute. Do I need to like put all 4.4 laps per minute, or is there any easier way to put the laps per minute or like divide it by something, like a different ways to say the answer?
So the thing is, the question dictates what you're doing. The question dictates it. And so since we're looking for rate here, we had to perform the division. We had to deal with the decimals. Are you saying that the decimals were your concern here?
Yes, decimals is good, like 4.4.
Yeah, so you got to work on that. That's really
okay.
You got to work on decimals. You know, we're identifying it, and I already know, Devin, that this is something that you don't feel comfortable with. Now I'm gonna go ahead and hound you the next time you text me saying, "Hey, thanks for class, coach. Oh, hey, how you doing with decimals? You practicing?
Oh, yes.
You're practicing? That's me. That's gonna be me. I'm gonna make sure you practice.
Yes, sir. I will do that part.
That sounds good, man. I got you.
Thank you.
Yeah, like I said, Frida. Yep. Again, it's really about practicing the plugging in. So what I'm gonna do here, everybody, is I'm gonna show you this next problem, and I'm gonna have you follow the 3 steps here. The 3 steps are this. First, ask yourself, are you looking for distance, rate, or time? And remember, of what? The distance of what? The rate of what? The time of what? And then number 2, we ask ourselves this. We ask, hey, what do we have? So what information do they give us? And then lastly, hey, what is our plan? Because I'm going to show you this example, and this is the last straightforward example that we'll see. And then we're going to start looking at some more complicated ones. Because if you can do these problems here, you're looking at a solid 31 to 45 on the ASVAB. If you can do these, you're in a good spot. If you can do the ones I'm going to show you in a bit, those, we're looking at a 51 to 75 range, perhaps 80, pushing it. So here we go. This is one where this is between that 31 to 45 range. I'm going to give you a minute and a half here to do your thing. So let me turn on my timer here. Let me pull it up. You have a minute and 30 seconds starting now. So first and foremost, everybody, we are looking for what? Distance, rate, or time? What are we looking for?
Rate.
Rate.
We're looking for
Rate.
rates. What gives it away, everybody? What
The
was
answers.
the most?
Because they say pure.
Ooh, Jose.
The
that's
question.
next level thinking.
It's in 11 hours.
Right. So they give you the distance and they give you the time. So you can assume that perhaps maybe you're looking for the rate. Yeah. Great way to think about it as well. And over here, speed, average speed. Exactly. And then the word per. In the answers, that gives it away. So allow me to go ahead and remove the timer. That way I have more space to work with. And so with that, we are going to go ahead here and write this out. We are looking for rate equals blank kilometers per hour. This is another way that you can see a rate. 1 unit slash the other one. That means per. The slash means per. Next, what do we have, everybody? What information are we given?
The distance and time.
Exactly. We're given a distance of 132 kilometers with a rate or with a time of 11 hours. So we have distance equals 132 kilometers. And then we have the time being 11 hours. And so when we set this up, what's our plan? This is step number 3. Our plan is going to be to set it up. Distance equals rate times time. We have 132 as the distance, as we saw. Then we also have our rate is what we're looking for. So keep that as is, times the time, which is 11, shown right here. And so there we are. 132 equals R times 11, or we can also write that as 132 equals 11R. If we divide both sides by 11, everybody, R would equal what?
12.
12.
12, correct. 12 what though?
Kilometers
12
per hour.
kilometers.
Kilometers per hour.
Because it's a rate. Kilometers per hour because it's a rate. And they also give it away right there. Kilometers per hour. And there we have it. That is answer choice B. Is anybody here feeling better about the setup part of the problem now?
Most definitely.
Oh, you're sounds good. All right. So with that said, let's see. Let's see how much more complex we can get. So what was that one thing I said earlier, everybody? It's not just about pointing out the distance, rate, and time. It's about pointing out what?
The question? Oh, wait. Oh, the goal. The goal.
Well,
But
yeah,
what
the
you
goal is
have-
the distance. But what did I say? It's not just about knowing, oh, yeah, this means distance. This means time. This means rate. We also have to know what those numbers are.
Representing.
Or
The
Yes.
plan.
What they're representing. So I'm going to show you a problem that might have more than one distance, might have more than one rate, might have more than one time. I'm not going to say which ones they are, but I'm going to ask you first and foremost with this problem. So let me just warn you here. I am not asking you to solve this problem. I am only asking you to first point out the goal and then split the information up into this bucket or this bucket. That's all I'm doing. All right, that's all I want. We will work together to solve the problem, but all I'm asking you to do is step 1, point out what you're looking for and tell me if it's a distance, rate, or time. Then you're going to look at the information that's given and tell me if that's a distance, rate, or time. That's all. We will do the setup together. I only want to give you a minute and only 1 minute here. Let me just get the clock ready. I'm only going to give you 1 minute here to try this out here. What's up, Charles? Go ahead and use the mic, boss.
Yo, I just wanted to ask you, Coach.
Yo,
So the 12 came from you dividing 132, 11 by 132, correct?
the 11, the 132 by 11. Yeah, that's what we're doing. Yep.
That's where the 12 came from?
Yeah.
Okay, thank you. And I also understood exactly what you were saying now about how to do the D equals R times 2 T. Yeah, I got a better understanding of it now, so thank you for that as well.
Hey, right on. Yep. And it's about knowing what those pieces mean. Exactly. Right on.
And all right, let's move it.
All right, sounds good. So let me get the clock ready here. Right here. Come on, work for me. I'm trying to lower it to a minute. Exactly. There it is. So I'm going to give you all a minute again to point out what we're looking for and tell me if it's a distance, rate, time. And then the rest of the information that's given, tell me if it's a distance, rate, or time. So 3, 2, 1. Let me go ahead and make this visible. And go. There you go. Was anybody looking at this, trying to solve it like sweet baby Jesus, kill me now? Was anybody thinking that?
Yeah, yes.
And welcome in, Dimitra.
Thank you.
So let's go ahead. I'm going to show you exactly how to get this done. Again, the main principles that we've been working with today were, again, Distance means the goal we're trying to achieve or how far we want to go. The rate always is indicated by per or for every or something like that, right? And then time is time. So let's see how well we've been practicing this. Let's just take it one step at a time. Here we go. In red, I'm going to highlight the question. Are we looking for distance, rate, or time? So here it says, how long did it take Donnie to get back home? So one more time, how long did it take Donnie to get back home? Everybody, when we ask how long it takes to do something, what are we typically talking about?
Time, like an hour or 2 or 3, whatever.
Right. Exactly. Exactly. If I were to ask, how long does it take to get to the mall? How long does it take to write a 1,000 word essay? Whatever it is, that's time. That's time. And another way that you can assure yourself, so how long did it take? If you were unsure about that, Jose, what's another way that you could figure out what you're looking for?
The answers that tell you hours.
Exactly. Jose, man, right there. The answers say hours, 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 hours. So we can for sure 100% say that we are looking for time. And so here's where a lot of us are going to make mistakes. So we are looking for time. Looking for time. So blank hours. But everybody, whose time are we looking for?
Donnie's.
Back home. Time back home.
Donnie's time.
We're looking for Donnie's time. Yeah. We're looking for Donnie's time, but for what situation?
To get back home.
And he's way back get home. Back to the crib.
Exactly. So pay very close attention, everybody. Everybody here notice that it says Donnie to get back home right here. Anybody else notice that when we're looking at drove to the beach, 60 miles an hour, 2 hours to get there. But then when you look at the other way around, on the way back, you drove at this speed. And then we look for how long on the way back. Did anybody notice that we're talking about two different situations here?
Yeah.
Yes, that's where we're kind of confusing that because it had it two situations now.
Okay. And so if you are looking at this and saying, hey, I'm a little confused right now, this is why you're here, obviously. So this is where I want everybody to go ahead and put their pencils down. Don't worry about trying to copy notes down or write things down as quickly as you can. Don't worry about all that right now. Remember the recording. If you miss anything at all, you can come back into the recording and take any notes that you missed. But it's better to actually understand it comprehensively and intuitively than to memorize it by writing. So just put your pencils down for a moment. This is where Mr. Duran is going to take over for a little bit. All right. So what we're looking for again is we're looking for the time and hours. We saw that, but just make sure to highlight this: to get back home. So allow me to make a new page here. That way I can have more, so I can have more room to really show all this information. So I'm going to write over here, back home. That was the ugliest K I've ever drawn in my life. So back home. And then we have to the beach. So I'm going to write that there and write that there. So what we're looking for is the time to get back home, right there, back home. So I'm going to write over here, we want the time to get back home is blank hours. And I'm going to highlight this because this is what I want. This is what I want. Now, let's go through one at a time here. Everybody, when Donnie drove to the beach at 60 miles per hour, everybody, 60 miles per hour, what does that represent?
Distance.
Rate.
Rate.
It would be rate. And it would be rate because we have the word per right there. Miles per hour. Miles per hour, that always gives away a rate. So rate over here, 60 miles per hour to the beach. Let's keep looking at the information. It took him 2 hours to get there. 2 hours, everybody, represents what?
Time. They're giving you the right and the time.
Time.
Time. Time equals 2 hours. And then just to mess around, just to have fun with it, Everybody, since we already have the rate and we already have the time, is it possible to find the distance?
Yes.
Yes. Just
Right? If we wanted to,
multiply
we could find the distance. We absolutely could if we wanted to. So let's just do it real quick just to mess around. Just to mess around. So distance equals the 60 times the 2. Everybody, 60 times 2 gives us what?
it. 120.
120 what?
120.
120 what?
Miles per hour.
Miles per hour.
Hours.
Hour.
What's distance written in?
Miles.
Just miles. Exactly.
Miles. Okay.
Just miles.
Wow.
You know.
No worries, because we're practicing this. We're practicing this. And trust me, I know more than anybody else here in terms of what making mistakes looks like and why it's necessary. So it's all good, man. It's all good. We're going to make these mistakes. So remember, distance is what you're trying to achieve. The number of miles, rate, speed, miles per hour, time. So what I'm looking at here is some more information, because we have on the way back, he drove at a speed of 40 miles per hour. So on the way back, 40 miles per hour, 40 miles per hour represents what?
The rate.
Wait.
The rate.
Yes. So that's going to be rate. So the rate here for the way back home will be miles per hour. Charles, I got to go ahead and mute you real quick, boss. The fire thing. So rate would be, again, 40 miles per hour. All right, so with that said, this is all the problem gave us, right, everybody? We're looking at this and we may be asking ourselves, what's up, buddy? My dog got up because of that sound. But we may be looking at this and say, okay, if we have tunnel vision and we're only looking at the time that we need and the rate, everybody, what's missing for us to be able to complete this problem? What do we need to see to be able to complete this?
The distance.
Distance.
Because you need something to divide rate with to get time.
Exactly. And so take a look here. Let's ask ourselves, where can we possibly find the distance? Because we see the 120 right over here, but we can't just throw that 120 over there. We can't just do that. If we were to do that, we need a good reason why. And so I'm going to put this right up here and I'm going to ask everybody. I'm going to come back in 20 seconds because I know my dog wants to get water. He's been sick lately. Sorry about that. But everybody, go. Good boy. Sorry, my dog suffers from a health condition that I can't control. So with that, if we are gonna replace the distance, what reason do we have? What implication, what inference can we make here?
Can we use it because that's what he used to from his house, I'm guessing, to the beach, and then like backwards? No,
Not exactly. Mohammed, you're not muted. I mean, your mic is on. I'm not sure why I can't hear sound.
Oh, okay.
Oh, there you go. I can hear you now. Yeah, I can hear you now.
Yeah, because the same. You're going to the same place. You're going to the beach, so it'll be same distance going back home. So we can use 120.
Yeah, so we can assume here, this
Yeah.
problem is written slightly poorly, and I'm the one that wrote this problem. But this problem is written slightly poorly, but what you can assume here, everybody pay attention, what you can assume here is this. Donnie drove to the beach, gets there. On the way back, he drives this speed, this time, whatever. So the implication is that Donnie starts here and goes to the beach. Then Donnie starts from the beach and goes back to where he was, which is home. Does everybody see how if we are talking about going from here to there, and then from there to here, that means that you went the same distance. Here to there is the same as there to here. Do we see that yet?
Yes.
Yeah.
The
Same
distances are the
situation,
same.
opposite direction.
Yes.
Yeah, exactly. The distances are going to be the same because if you go from here home to the beach, it's not going to matter. You can go here to there or there to here. It's going to be the same exact distance. Same distance. So one more time, yes or no, does that make sense?
Yes, sir.
Yes.
Right on. Right on. And so with that, booyah, what we can do here is we can take this distance and we can say, hey, yo, there's our distance. There it is right there. And so for those of us who are asking, hey, when are we going to do a problem where we're looking for time? Here we go. Because now what we can do is we can solve this by using D equals R times T. And now all we have to do is plug and chug and we're good. Hey, Nancy, thank you. And so with that, we're going to have 120 for the distance. We're going to have what for the rate, everybody?
40 miles per hour.
40.
And then the time is just T. So before we continue, just one more time, let me remind you, if you're asking, yo, hey, Coach Anderson, how did we get 120 for distance? How did that happen? Well, the way that we got that, remember, is this. If we're going from here to the beach and then the beach back home, those distances are the same. And so this distance that we found earlier with this rate and time is the same distance back home. And that was the implication. Now we have all of this set up, and now we can solve by dividing both sides by what, everybody?
40.
40.
Correct. Because now that we did that, goodbye to the 40. And now the 120 divided by 40, we can first start by getting rid of the zeros. So we have 12 divided by 4, which is 3. 3 what, everybody?
Hours.
3 hours.
3 hours
Per hour.
3 hours for what?
Going back home.
Donnie got back home.
Going back home.
3 hours to get back home. And there it is. 3 hours to go back home. And so the 40 was the rate because that's what we were given for the rate going back home. So if you're asking, hey, why is this the rate for back home and not this one right here? Again, because we're talking about back home, the time to get back home. So this is let me actually pause right now. Remember how I said everything in the same formula needs to represent the same thing. Everything in the same formula needs to represent the same thing. So this time, this rate, and this distance all represent back home. We were asked to find how long it'll take to get back home, which means that the rate and the distance that we use need to represent the rate going back home and the distance going back home. And that's the information that we found in the problem over here, because we found, hey, on the way home, back 40 miles per hour. So that's the rate we need to use for back home. And then how long did it take back home? Again, that's what we're looking for. And then by implication, we had 120 on the way there for the distance. And that's going to be 120 on the way back. Right on, Ben. So Jordan, let me know if that makes sense too, boss. Let me know if that makes a little more sense. Oh yeah, there we go. So with that, that's why I had to take my time on that problem. This is one of my favorite problems because this is one of the more common types of rate problems you'll see on the ASVAB. There's actually quite a few. There's two objects separated. There's two objects coming together. There's two objects catching up to each other. There's one object with two scenarios, one object with multiple scenarios, and one object with overall distance, overall rate, and overall time. There's literally 6 different types of rate problems. Well, and then there's the simple DRT problems where they give you 2 and you have to find the other. So like they give you distance, you have to find, or they give you distance and rate, find time, give you time and rate, find distance. So there's really 7 different types of rate problems. So my question for y'all is this. In December, because I haven't made the schedule yet, for December, would you guys like me to commit as many classes as it takes to go through every type of rate problem that you could ever see?
Yes, sir.
Got it. Sounds good. Because I was planning on doing that for rates, and I was also planning on doing that for percents. So going over every type of word problem you'll see with percents, simple compound interest, looking at taxes and discounts, looking at payoffs for loans and things like that. So I want to go ahead and actually commit to making a full series. That way, I'm also going to put in a lot more money for the recordings to make sure that they're crisp and clear on the website. I will be changing a few things in December. Trust me, we're not even done yet with those updates. So with that, in December, DRT all. So I'm going to take at least 2 or 3 classes for that. And then percents, we'll do as many classes as it takes for that. Perfect. You take your test the day before Christmas? Hey, no worries. Hey, Malik, go ahead. Hey, you got this, Antoine. Again, keep practicing one day at a time. Malik, do you have a question? Or were you agreeing with everybody?
No, I have a question. Can you hear me?
Yeah. What's up?
I'm super confused when you get to the end and you start dividing, because the last time you divided another way, and then this time you divided by just canceling out the 40 and then having the times. I think I get messed up a lot when I get to this part because I might do the wrong type of division. So I'm just curious why you didn't do the other type of division on this problem when you did it on the last couple of problems.
Yeah. So it's going to give you the same result. I was just using a different technique. So thanks for pointing that out, because I can go ahead and actually just make sure I clarify for you. I got you. So this is what it would have looked like. The 40 dividing into 120. And what we would have asked was this. We would have asked, okay, how many times does 40 go into 1? Can't happen. 40 going into 12? Can't happen. But 40 going into 120, that's going to be 3 times. And so that's where the 3 comes from. And the technique that I used, Malik, was this. I said that when you're dividing numbers that both end in 0, you can cancel out the 10s, or you can cancel out one of the zeros. That's a popular rule. Not everybody knows it, but it is a popular rule for divisibility that we do want to make sure we pay attention to. Does that help out a little bit there?
Yes, that helped me a lot. I really appreciate it. Thank you.
No worries. Hey, you got it. Dimitri, go ahead, and then we're moving into the next problem here.
I guess my question is, it's almost like you have to solve the first portion of the problem to be able to get the distance to work it into the second portion.
Yes.
Is that how we're looking at it? Because we got the distance. We got the distance, and then we had to turn around. Once we got the distance, we had to plug it in to get the back home portion.
Yep. And that's why knowing the story is so important. Understanding how the story flowed and what information we had to work with. That's the point of today's class. Being able to look at the information we have and apply it to what we need to get.
Okay. Thank you.
Hey, not a problem. So what we're going to do now here, everybody, is we got some practice time here. So really what I want you to do here is, first off, let me mute everybody real quick because it looks like we got some background noise. Boom. So here's what's going to happen, everybody. I'm going to show you unique problems. I'm going to show you problems that, whoops, sorry, Sia and Dimitra. I didn't mean to ask you to mute yourselves. I was just trying to lower your hands. So what we're going to look at are problems that you have not seen yet. Because the thing is, I would not be a good ASVAB coach if I only did one type of problem and then only show you that one type of problem while we practiced. That's called fake teaching. Fake teaching is when I set you up and I tell you exactly what to do before you get to do it. And then you get that false sense of confidence and you walk away like, yeah, I'm good. But no, I need to help you actually sort through the information. So I'm going to show you, I'm warning you right now, this problem, you're going to have to come up with the technique on your own, but I can promise you it is distance, rate, time. As long as you are focused on representing the same formula with the same things, then you're going to be good to go. Okay? Represent the same formula in the same way with the same representations. You're going to be good. All right? So just do your best. The first minute, just focus on pointing out what you're looking for and then grabbing your information. The second minute, if you're ready to calculate, sure. Or again, setting it up. If you don't solve the whole problem in the 2 minutes, it's okay. It's okay. I'm not going to crucify you for it. I just want to see you try to get a setup done. Yes or no, everybody? Does that make sense? Right on. So let me go ahead and set up the timer here because I need to increase it to 2 minutes very quickly here. And then once I have this, then we are good. Alrighty. And so I think I'm looking for countdown 3. Perfect. Let me just open a new document. We are set. Correct. All right, there we go. 3, 2, 1. It should pop up in a moment. There we go. All right, so let me reset it for y'all. All right, so here we go. 3, 2, 1. Let's try it out. So let's go. So help me out, my party people. Let me go ahead and give you all the mic just in case y'all do want to speak. Just remember, when you are done speaking, unmute yourself or mute yourself again. So everybody right here. Starting from home, Greg drove 40 miles per hour. What am I doing wrong?
You're not reading the question. You're not reading the question.
Right? I ain't following my own rules, man. Come on, Anderson. All right, that kind of hurt. But here we go. What was Greg's average speed throughout the whole trip? This is the question. Now, everyone, what are the key words that we can highlight to really solidify what we're looking for? Greg's average speed.
Speed and rate. I mean, par.
It's got to be the average speed.
I love it.
Average speed.
Multiple ways to point this out. We have average speed, and then we have the word per in each of these. So what are we looking for?
Which is
we are looking for
the
rate.
rate.
We are looking for the rate. So we want the rate. But here's the most important part, everybody. Rate for what?
Entire trip.
Say it again, loud and proud.
The entire trip.
The entire trip, everybody. We are looking for the rate for the entire trip. For the entire trip. One more time, everybody type it out into the chat box. We are looking for the rate for the entire trip. Type it out. We want the rate for the entire trip right here. We cannot ignore that fact. This is where, if you are paying attention to the problem and you're actually sorting through the information, you're going to have an easier time. If you just see miles per hour and you stop right there because you see, oh, that's a math word, that's what I'm looking for, this is where things get difficult. This is where things get difficult. So allow me to mute those folks. Amberlyn, sorry if you were saying something to me. It sounded like you were speaking in open air. So with that, everybody, here's my question to you. Put your pencils down, everybody. For a second, put your pencils down. If we're looking for the rate for the entire trip, that means that we need the distance and the time for the what?
For the entire
The
trip.
rate.
For the entire trip. If we are looking for the rate for the entire trip, that means we need the distance for the entire trip and the time for the entire trip. That's what I mean when I say in the same formula, represent the same thing. That's what I mean. Is that starting to make a little more sense now, everybody? If you're looking for the rate for the entire trip, you need distance for the entire trip and then my big old head's in the way. And then we need the time for the entire trip. That's what I'm saying here, everybody. This is how you start really understanding word problems. If you are good with this, everybody give me a yes or no if you're good with this. Give me a no if you're not. Be honest. But if you're good with this, knowing that if you're looking for the rate for the entire trip, you need the distance for the entire trip and the time for the entire trip. If this is making sense to you in terms of the connection that we need to build, then these numbers up here are going to start making a lot more sense. They're going to start making a lot more sense. And let me show you how. This is where we start getting to it. So let's check out the information that we have. So we've already identified, okay, what we want and what we would need to get there. Let's see what we have. So let me just zoom out just a little bit here so we can see everything. And I'm going to start writing some information down. So what we see here is that it says, starting from home, Greg drove blank miles per hour for 2 hours. He took a break And then he drove this many miles per hour for another couple of hours. And then he arrived at his sister's house. So everybody, the entire trip is going from home and arriving at his sister's house. True or false?
True.
Right. That's true. That is absolutely true. We are going from Greg's home to his sister's house, and we're basically going to find the distance all the way through and the time all the way through. If we find both of those things, then we can find the rate all the way through. So here we go. Starting from home, he drove 40 miles per hour for 2 hours. So let me just write this as part one. Let me just write this as part one. Part one, we see that we have 40 miles per hour. Everybody, 40 miles per hour is what kind of a unit?
Distance. Wait. Yeah. Wait. No. I mean rate.
no,
Rate.
no,
I
that's
got
rate,
that
that's
wrong.
rate, bro.
Rate.
That's rate.
Ray, I messed up.
It's rate.
Ray.
Oh, brother.
You guys see why I'm taking this break next week, right? So I'm joking. I'm joking. I would never say that. So 40 miles per hour, that is the rate. That is the rate. I love y'all, man. You guys are awesome. So rate. Y'all make a bad day good, man. So rate right there. Then we see that it says 2 hours. What does that mean here?
Time.
Jose, do you agree?
On hours? Yeah, it's time. It's because the one threw me off, the 1 hour break. That's what.
Oh, don't worry. Yeah, we're gonna handle that. I got you. So part one here, we have 40 miles per hour in 2 hours. Everybody, what does that mean? What is the distance for part one if we did that then?
80 miles.
Yeah, the distance would be 80 miles. And this is for part one. For part one of the trip, we see that it was 80 miles. And how much time was it for part one, everybody?
2 hours.
2 hours.
2 hours. So this is really what I'm trying to show y'all here. So part one of the trip, we see that we went 80 miles and we went 2 hours. That doesn't mean that we have everything we need here, because the 80 miles is just part one of the trip. We have part two and we have part three. Once we get everything together, then we can find the entire trip distance and the entire trip time. So Simone, I'm going to answer that question right now. I got you. So part two, everyone, let's go ahead and use purple for part two. Let me zoom in a little bit here. So part two. So part two, what we see here is that it says took a 1 hour break. Okay, so let me write that right there. 1 hour break. Everyone, in that 1 hour break, what was the distance traveled in 1 hour?
Nothing.
0 miles. But how much time did those 0 miles take?
1 hour.
An hour.
1 hour.
Right there. So right there, Simone, we are counting this. We for sure are. We're counting it as 0 miles, but we're counting it as 1 hour because we did take a 1 hour break. Does that make sense so far, Simone? Booyah. And so with that, let's look at part three of the problem. So let me use a different color now. I use green. Right here it says, and then drove 30 miles per hour for another 2 hours to arrive. Okay, sounds good. And those of us with OCD, I got you. My bad about that. So boom. So part three here, I'm going to repeat what I just highlighted. Part three is, hey, we had a rate of 30 miles per hour and we have a time of 2 hours again. So everyone, what's that distance going to be? What is distance equals rate times time? That's going to give us distance for that was what?
60.
60.
60 what?
Miles.
Miles per hour.
Miles. So this is where we got to get that difference. No, you're good. Again, mistakes happen. Remember, miles per hour, the word per, that's a rate all day. Distance, single unit, single unit. So that would be 60 miles. Yeah. Again, no shame in trying, David. Hey, David, I appreciate you trying, bro. Because I bet you right now, you were just like Christian in the beginning. Christian started about 2 or 3 months ago. And Christian made all the mistakes in the world in the beginning. Then he became really confident over time. This is the same way for you, man. Same way for you. Work through those mistakes. Make mistakes confidently. So that way you feel that little bit of shame when you're like, oh, dang, I'll get it next time. That's what you want to do. So we have a distance of 60 miles. Everybody, how long did it take to reach that 60 miles?
2 hours.
2 hours. 2 hours right there. So everybody, this is where it's so important to understand, again, the concept of distance, rate, time. In the same formula, we need to represent the same thing. So if we're looking at the rate that we're looking for the entire trip, then the distance we need to use is the one for the entire trip, and the time we need to use is the one for the entire trip. So here's what I'm going to do, everybody. I'm going to write this right here. So here we have entire trip. We have the entire trip here. Watch this. So we're looking for the rate. What we do have, let's look at the distance. The distance for the whole trip is this, everybody. It's going to equal the 80 miles right there from part 1. 80 miles from part 1. And we're going to add that with the 0 miles from part 2.
Plus the 60.
Plus the 60 miles from part 3. Everybody, if I add up all of those distances, will that be the distance for the whole trip?
Yes.
Yes.
140.
Yes.
Yeah.
Yes.
40.
And that would be 140 miles for the whole trip. And so that's our distance for the whole trip right there. And let me actually not use red or green. Let me use red instead. 140 miles. So whole trip, distance for the whole trip is 140 miles. Now we're going to ask ourselves, what was the time for the whole trip? And so here, I'll do it over here. So now time for the whole trip, that's going to be what? Well, we're going to grab the 2 hours from over here from part 1. We're going to have the 1 hour break right over here. Although we didn't move, that still counts. And then we have part 3, 2 hours again. And so when we add everything up, everybody, the time for the whole trip is what?
5 hours.
5
5
hours.
hours total. Yes or no, before we do anything else, do you understand how we got to the distance for the whole trip and the time for the whole trip? Yes or no?
Yes.
Yes.
Booyah.
I get you. Just the one that kind of threw me off, coach, was the 1. Like the 1, because I thought the 1 had to go with the 2, the 40, but I see now. Like, that's what I got to watch out. That's what messed up everything for me.
Hey, no worries, man. Because again, we're working through these mistakes. And so we have our distance. We finally found it. Our distance equals 140. Our time, so 140 miles. Our time equals 5 hours. And so when we fill this in, D equals R times T. What we'll receive is 140 equals R times 5, which is the same thing as saying 140 equals 5R. Everyone, what will we do to both sides to complete this problem?
Divide by 5.
Yeah, divide.
On both sides?
Both
Divide
sides.
both sides by 5, exactly. And once we do that, that's bye-bye right there. And we can perform long division here just to make sure everybody's confident with this. And I also will dedicate 2 days in December to mental math. I definitely will, and calculating quickly. So I'm going to talk about that in a moment here. But 5 goes into 1, it doesn't. 5 goes into 14, it does. Twice. And then we bring that 0 down. 5 goes into 40. How many times, everybody?
8.
8 times. And we have 28 right there. 28 what, everybody? The answer is 28 what?
Miles per hour.
Miles per hour.
Miles per hour. And there is our answer. Anybody here breathing a little easier than we did before?
Yes.
Boom. And
I
there
got
it
the
is.
wrong answer.
You get the wrong answer, Jomari?
Yes, sir. I didn't include the 1 hour because it's zero
Did you get
distance.
35 for that then?
Yeah.
Yep.
Yep. That's why I put it there. That's why I put
Sir,
it there.
can you zoom out a little bit for me?
Oh, for sure. I got you. So I'm gonna do this. I'm gonna make sure everybody gets a chance to take pictures here in sections because I know it's a lot. So I'm gonna give everybody a chance to take pictures here. Then I'm gonna make a suggestion for next month's classes, and then we're gonna do 1 or 2 more problems, and then we are good for the day. So here it is. Go ahead, take your picture. I'm gonna count to 10. 4, 3, 2, and 1.
Jeez.
So here's part 1. Here's part 1. No, I gotta look good because I know some of y'all are gonna see your family for Thanksgiving. Then they're gonna be like, oh, who's your coach? Right, cool. So this is part 1, part 2 over here, and then we're gonna have part 3 coming up. So there's part 3. Yeah, Joseph, I know this is long. I'm telling you, this is an example of a 51 to 80 problem on the ASVAB. If you're able to do these types of problems, like as complex as they might seem, you're fixing yourself up for a high score in the ASVAB. So, and I can't, just skip around these problems. I do need to show you these because if you're willing to go for it, you can get it. And so here's the entire trip, and here's the last one. Ryan, this is already in there. Yeah, this is in there. This is under distance, rate, time. All right, so there it is. There's total. So I wanted to ask you guys this, Sia, before I take your question. I want to ask you guys this. Would you guys be down on top of the, all the distance, rate, time problems, all the percent word problems? Are you guys cool with me running a couple of sessions on simple, not simple, but straight up calculations? So multiplying with decimals, multiplying 2 digits by 2 digits, 3 digits by 2 digits, like bigger numbers, dividing decimals, long division, mental math skills. Are you guys cool with me taking some time for those as well?
Yes.
Yes.
Okay. Sounds good. I think you guys deserve that. Especially we haven't done mental math since like July, August. So I do think it's time to redo one of those classes. So, or plenty of those classes. So, okay. So December is really all going to be about distance, rate, time, percents, and then mental math. If there's room, I'm going to add in another topic, one that's also important, probably polynomials, distribution, and factoring. That's the backup. But yeah. All right. So with that said, how are we feeling on a scale of 1 to 10 so far? How are we feeling? Alex, on the math knowledge, I've seen a lot. Yeah, a lot of combining like terms, factoring, distributing. Yeah, I've seen it.
Like a smooth 7.
Hey, that's better than we were before. A lot of y'all were looking at a 3, 4.5, Lizzie, 5s, 5.5s. So yeah, I ain't gonna forget that. So with that, I'm gonna take some questions really quick here. So Sia, you're first.
Hi. I did everything right, but I just want to say this out loud. So we need to take in all the information with the numbers because I ignored part 2. I completely thought, oh, it doesn't matter because it said 0 distance. And then I just thought maybe the 1 didn't matter.
Yeah, so entire trip. So here's another question. If I would have said, yo, if we're talking about a taxi driver and we're asking what was the taxi driver's average speed for his entire day of driving? If the taxi driver took a 1 hour break in the middle of a shift, if we're talking about the entire shift, the entire day for that driver, we're still going to count that break. We're still going to count that break. Unless they say unless they specifically say the break doesn't count, they're giving you that information for a reason. And so you want to think of it that way. When you're looking for the rate for the entire trip, you need the total distance for the whole trip and all the time that we took to get there, breaks included, because we're talking start the moment that we leave the house to the moment we get to the sister's house. That we're counting everything in between, and the break in between counts as that. So let me know if that makes a little more sense there.
Yeah, it makes sense. I just thought I was being smarter than you, and I was not. Thank you. Appreciate it.
Try again. So let's go ahead and get Mohammed up next.
So I got a question. Can you hear me? Yeah. Okay, so how long the time for each question? It's 2 minutes.
So for the arithmetic reasoning,
And,
you are going to be
as well.
getting about 2.5 minutes per question.
Okay.
And then for the math knowledge, you get about 1 minute 15 seconds.
Okay, can you go back to the distance question? No, back. No. Yeah, that one. No, the other one. The one before that. Because here's how I solved it, and what is it? The same distance. Remember the 120
this one right here.
distance.
Same distance.
Okay.
Yep.
So what I did, I assume it's DF mean Donnie forward equal Donnie back. So what I did, I just you know what I'm talking about, right?
Yeah, right here. Yep.
So you make pretty much fractions and multiply the whatever it be like.
No, I simply use the idea that the rate to the beach and the time to the beach gives me the distance to the beach, and the distance to the beach is the same distance back home.
Yeah, but
so that's the connection you had to make.
Yeah, but if you do 6 on 20 equal 60 on 2 equal 40 on t, you find t like that.
You can do that. Yep, exactly. Because in that case, distance equals rate times time for both, but you have the same distance. So that means rate times time.
That's why I say d equal d. So pretty much I plug the numbers in it.
Yeah, you could have done that.
Okay.
Yeah, absolutely. Good question, by the way. Good question. So let's go ahead and take. Okay, so it looks like what I'm going to do is I'm going to answer these questions. I'm going to give you guys the final problem. I'll let you guys take this with you home, I guess. But go ahead and try the problem out on your own, and I'll give you the answer when you need it. Okay. So we'll do it that way because I see that we are running out of time here. So I do want to make sure that our questions are answered. David, go ahead.
All right, yes, sir. First and foremost, you gotta tell me where them glasses came from, or because that was legendary. Also, can you go back to part 1 because I forgot to take that.
Yeah, right here.
But other than that, yeah, man, you gotta tell me where you get the shades from. I'm gonna need that.
Yeah, you know. So if you guys didn't know, one of my idols, I guess, or favorite characters in movies, Iron Man. These are the Iron Man glasses.
No way.
Yeah. They're $10, man. They're $10 on Amazon.
What?
Yeah, I got a whole case of these, so we're good.
Okay, hey, you gonna have to send me one, a pair.
Yeah, these are fly, man. These are fly. I actually just got a new car today, and wearing these with them, I feel nice. So go ahead. All right, so up next, Drea, go ahead.
Can you hear me well?
Yes, I can.
Okay, so yeah, you just broke this whole problem down to me. I guess my main question is, what type of problem? You said there would be about 7 different types of distance rate type of problems. So this one is, I guess how I kind of summarized it, like the last one we did with Donnie as well, is these are problems that are associated with the same distance. Is that a certain?
Yeah, so I can actually write these down for everybody for sure. So let me go ahead before I give you the last problem of the day. Let me go ahead and add this over here. So everybody, let me go ahead and write down the different types of distance, rate, time problems. I think this is a fair thing to do for sure. So Drea, thank you for pointing that out. And then Monique, thanks for being patient. I got you up next with your question. So the 7 types, there could be more. As I write these down, I'm going to realize if there is another one, but 7 types of distance equals rate times time problems. So these are the types that I've identified over my career. So number 1 is a simple one. It's simple because they give you 2. So they give you 2, find the third. So given 2, find missing. So does that make sense, everybody? The first one, again, it's just the simple ones like, oh yeah, you're driving 40 miles an hour for 5 hours, find the distance. Like those simple ones. That's what I mean. They give you 2 of those 3 pieces. You got to find the third. So far, that makes sense? All right, cool. Oh, I love Spider-Man too. Don't get me wrong, guys. Hey, I love Marvel in general. Iron Man is just what I grew up on. So number two. So number two is when you have multiple distances, rates, or times. Okay, when you have multiples. So basically, when you have two objects separating. So basically, like two cars. So for example here, like two cars driving away. Two cars driving away from each other. Number three is when you have two objects colliding. So basically like two trains headed toward each other. Two trains headed toward each other. Then number four would be two objects catching up to each other. Have you guys seen those problems where they say like this car is going and then this car tries to catch up, or this plane is going and this plane's trying to catch up? Yeah, so two objects catching up to each other. So two objects catching up. So basically one plane catching up to another. Then we have the fifth one. The fifth one is going to be, so this is where we start getting into not two objects, but we have one object and we might have multiple scenarios. Like we just saw, okay, we got this person driving to his sister's house. So he goes this distance, takes a break, goes this far for this long. So basically here, for catching up, yeah, you do subtract. Yep, for sure. And so number five, what we got going on here, one object, multiple scenarios. So basically they're going to have you like find total distance, finding total distance, rate, or time. So like the average speed for the whole trip, the time for the whole trip, the distance for the whole trip, right there. Also another one, number six, where you have one object, two scenarios connected, though connected. So for example, the one with Donnie driving to the beach and driving back, they're connected because they had the same distance. So that's another type of question there. Whoops. Cool. So right there. So basically, one object, two scenarios. So you have two formulas connected in some way. So it could be they both have the same distance, they both have the same rate, both at the same time. Who knows? But they're connected in some way, shape, or form. And I believe number seven, what was number seven? Must have actually covered that already, because you have one object, multiple scenarios, one object, two scenarios. The simple is one object, one scenario. So this is one object, one scenario, one object, two scenarios, one object, multiple, two objects separating, colliding, catching up. And I believe that, the seventh was just going to be like an advanced, just a mix between any of these. So mixing any of the above. And so those, like, if you ever see a problem like that on the ASVAB, I haven't seen one yet, but I can guarantee you if you do on the CAT ASVAB, you're probably doing really well. You're probably looking at like a 91 to 99 if you're getting a mixture problem with all of these together. Like some way, some form, how mixing these up in that way, trying to confuse you, you're looking at a 91, 99 for sure. No, there's no way that you would get kicked into that type of problem unless you were on a hot streak. If you got like 6 or 7 in a row, then it's probably going to give you a problem like that. Remember, the CAT ASVAB is adaptive, computer adaptive test. CAT, C-A-T, computer adaptive test. It adapts to how many questions you're getting right or wrong. You get more right, questions get slightly harder. Get more wrong, they get slightly easier. So if the questions are getting harder, it means you probably get the last question right. So you should be happy. If the next one looks like, yo, I have no idea what's going on. Oh, wait, I got the last one right. Cool. But crap. That's probably how you should look at it. So with that, if you didn't know that, there's some food for thought for the day. But these are the 7 types of distance, rate, time word problems. So one set is literally one object with one event, 2 events, or a total event. Then you have 2 objects, either driving away from each other, driving toward each other, or trying to catch up to each other. And the last is just mixing any of these in some way, shape, or form. I can think of a way to really mess you up with these. Like, it's really easy to make a problem like that, but they are very confusing to try to tackle. Yeah, it does, Simone. Yeah.